Today's lesson we are going to look at Mathematics 2611 Linear Algebra 2. The topic for today is Gram-Shmidt process. This is lesson 102. Let us start. The question normally comes in this format. The first question will ask you to actually find the inner product, and then you'll be given a definition like this. And then the second question, after answering or finding the inner product, we'll say find the orthogonal or orthonormal of the following subset in this R3, and then you'll be given a subset like this. So in order for us to find the orthogonal and the orthonormal, we need the subset and the definition from the inner product question. In this lesson video, we are going to look at solving problem question. We are not going to dwell much on the basics and the equations in Gram-Shmidt process. Do watch lesson 101 of Gram-Shmidt process. Also have a lesson video where we talk about the inner product, how to answer those questions. Now in this question we need this definition. Since we have it, it's fine. And then we also have our subset. So the first thing that we need to do, we need to label our subset or vectors in the subset as U1, U2, and U3. Now for us to actually perform Gram-Shmidt process, we need to use the following equations. Now the first one is V1, which is equals to U1. So basically the orthogonal is another set of vectors which is V1, V2, V3. So this equation is to find V1. V1 is basically equals to U1, and then V2 it's equals to U2 minus the inner product of U2 and V1 all over the inner product of V1, V1, all multiplied by V1. So this is the equation to determine V2. Now to find V3, the equation will be V3, it's equals to U3 minus U3 V1, the inner product of U3 V1, all over the inner product of V1 V1 multiplied by V1 minus the inner product of U3 V2 all over V2 V2 and then multiplied by V2. So I hope you can see the trend. If we were to go to V4, we are going to find another part which is an extension of this one. So since we have three vectors in this subset, we are going to end with V3. So basically our orthogonal is V1, V2, V3. In this lesson video, we are going to find the orthogonal of this subset, and then the next lesson video we are going to continue finding the orthonormal. So to find V1, we are just going to V1 it's equals to U1, which is equals to our U1 is actually this 1 0 1. We are done. We have our V1. Then V2, we are going to need U2 and the inner product of U2 and V1. So normally what I do, I simply determine the inner products first before I apply the equation. So the inner product of V1 we are going to use this definition. In this definition, we can consider this as, since we have v1, this will be the first element of v1. This will be the first element of the second v1. But since we have the very same v1, we are going to use the very same elements. You will see when we find the inner product of this part. For this part, it's simple because we only have the very same elements throughout. So x1, we take it as the first element. X1, it's 1. This is the x1 I'm talking about. Y1, it's still this one because we are dealing with the very same vector. Plus, this plus is from this definition. 3, this 3 is this one. X2, which is the second element, it's 0. Then the second x2, it's still 0 because we are dealing with the very same vector. I'm sorry to write on top of this subset, but I hope you can see it's visible enough. X3, it's the third element, which is 1. So you're going to say 1 multiplied by 1. Now simplifying this, we have 1 multiplied by 1, it's 1. 3 multiplied by this 0 is actually 0. Then 1 multiplied by 1, it's 1. So the inner product of v1 is actually 2. Then from here, let us find the inner product of u from the equation of u2 v1. We are actually here, u2 v1. u2 v1. So this is our u2, and then our v1 is actually this one, or we can say u1. So looking at the definition, let us quickly write the definition. It's x1 y1 plus 3x2 y2 plus x3 y3. Then let me quickly write our vectors. v1 is 1 0 1. Then u2 is -1 0 1. So I want us to actually focus here. This will be our x1, this will be our y1, this will be our x2, this will be our y2, this will be our x3, this will be our y3. So looking at this inner product, u2 v1, let us substitute. What is our x1? It's 1. What is our y1? It's actually -1. Plus, you can see that our definition has 3, so we're going to put 3. Our x2 is 0, our y2 is 0. Plus, x3 is 1, y3 is actually 1. So in this case, 1 multiplied by -1 is -1, and then we have 0 and 1. 1 minus 1 is actually 0. We have our inner products. Now we can go ahead and check the equation. We said the equation is to find v2, it's u2 minus the inner product of u2 v1 all over v1 inner product of v1 then all multiplied by v1. So we have all the values. v2 it's equals to u1, it's actually, let us go up, yeah, this is our u1. Then we can just plug in here. It's actually u2, not u1, I mean 1, and then minus This, we have found that it's 0 divided by this, it's 2, and then multiply by v1. v1 is 1, 0, 1. Then we need to simplify this. v2 is equals to 0, 1. So this is just a scalar multiplied by this vector. So 0 divided by 2 multiplied by this. This will be 0, 0, and 0. It's actually undefined, 0 and 0. So we can conclude that this is actually our v2. So we have v1 and then this is our v2. v1 is equals to 1, 0, 1. Now we are looking for v3. Going back and checking the equation for v3, it says u3 minus the inner product of u3 and v1, v1 and v1, all multiplied by v1 minus the inner product of u3 v2, the inner product of v2 v2, all multiplied by v2. So we need to find the inner product of this, the inner product of this, this, and this. Now the inner product of this, we already know that we got 2 from the previous vector. Now let us find the inner product of u3 v1. Let us quickly write that definition. It's x1 y1 plus 3x2 y2 plus x3 y3. And then we are going to focus on u3. u3 is equals to -1, 1, and 1. And then v1 is 1, 0, 1. So this will be our x1, or let's say this will be our x, this will be our y. So let us go ahead and find the inner product. x1 is -1, y1 is 1 plus 3x2 is 1, y2 is 0 plus x3 is 1, 1. -1 multiplied by 1 is -1. This will be 0, and then plus 1, we get 0. So this inner product, we find that this is equals to 0. Then let us go and find the inner product of u3 v2, u3 v2, using the very same definition. So v2, we have found that v2 is equals to -1, 0, 1. Then our u3 is actually this one. Well, let us write it with this color. u3 is 1, 1, 1. Actually it's -1. Then from here, let us find the inner product of this. Our u3 is x, our v2 is y. So x1 is -1, y, it's -1 plus 3 x2 1 0 plus x3 1 1. Simplifying this, negative and negative is positive. 1 plus 0 plus 1 is equals to 2. This is the inner product of U3 V2. Looking at the equation, I think we are all set. Now we should find V2 V2, the inner product of V2 V2. Let us go ahead and find the inner product of V2 V2. So our V2 is this one, we just wrote it, it's -1 0 1. So let us find the inner product using the definition. So you're going to have -1 -1 plus 3 0 0 plus 1 1 1 0 1 2. So the inner product of V2 V2 is the same as the inner product of U3 V2. Now we are good to go. We can go ahead and find our V3. To quickly write the equation, V3 is equals to U3 minus the inner product of U3 V1 over V1 V1 multiplied by V1 minus the inner product of U3 V2 inner product of V2 V2 and then multiplied by V2. V3 is equals to U3, it's -1 1 1. The inner product of U3 V1, we got 0. U3 V1, it's actually 0. So you have 0 divided by V1 V1 is 2, and then V1 is 101 minus the inner product of U3 V2. Let us quickly check. We found that it's 2, so we have 2 divided by the inner product of V2 V2, found that it's also 2. Then we have V2, it's -1 0 1, -1 0 1. Then from here, let us actually simplify this. V3 is equals to, let us leave the first vector. This is supposed to be negative, not equals to. Minus, this will result into 0. Then let us simplify this one. It's 1. We have 1, we have -1 0 1. So V3 is equals to -1 1 1. This negative multiplied by this -1, we are going to have a +1 0 -1. Performing this operation, V3 -1 plus 1 is actually 0, 1 plus 0 is 1, 1 plus -1 is 0. V3. Now to actually wrap this up and find our orthogonal, we are going to present it like this. We are going to put our V1, V2 and V3. Then the actual answer for this question, V1 is 101, V2 -101, V3 0 1 0. So this is the orthogonal basis for the given question and the definition. That's it for this lesson video. This is Wahula SJ. Thank you very much.